Welcome back to our channel. Today we are diving into one of the most fascinating topics in geography, Earth's composition, minerals, rocks, and the rock cycle. Stay tuned till the end because this one will give you a complete understanding in one flow. Earth's composition. The Earth is made up of two very distinct parts, its outer layer or crust, which is solid, and its interior, which is hot and molten. About 98% of the crust is composed of just 8 elements: oxygen, silicon, aluminium, iron, calcium, sodium, potassium, and magnesium. The remaining portion includes elements like titanium, hydrogen, phosphorus, manganese, sulfur, carbon, nickel, and many others. Elements rarely exist on their own. Instead, they usually combine to form minerals. The outer layer, also called the lithosphere, consists mainly of granitic rocks rich in silica and alumina, we call the sial. The inner layer is basaltic, rich in silica, iron, and magnesium. This is known as sima. Sima is denser than sial, and that's why sial seems to float on denser sima, like a lighter layer on top of a heavier one. Together, sial and sima form the Earth's crust, which varies in thickness from 3 to 4 miles under the oceans to about 30 miles under some continents. Parts of the crust covered by water are called hydrosphere. Surrounding the Earth up to 15 miles high is the atmosphere, a mass of gases. The cryosphere includes all the frozen parts of the Earth system: snow cover, glaciers, ice sheets, ice shelves, icebergs, sea ice, lake ice, river ice, permafrost, seasonally frozen ground, and even solid precipitation. Minerals are naturally occurring substances with an orderly atomic structure, definite chemical composition, and unique physical properties. They are usually formed from 2 or more elements, though some exist as single element minerals like sulfur, copper, silver, gold, and graphite. Around 2000 minerals have been identified, but most common ones belongs to just 6 major rock forming groups. Minerals originate from hot magma inside the Earth. As it cools, crystals form which later solidify into rocks. There are also organic minerals such as coal, petroleum, and natural gas existing in solid, liquid, and gaseous forms. Physical characteristics of minerals. First is crystal form, shapes like cubes, octahedrons, or hexagons. Second, cleavage, that is the tendency to break along flat planes. Third, fracture, breaking irregularly, not along cleavage. Fourth, lustre, appearance can be metallic, silky, or glossy. Fifth, color, natural or due to impurities. For example, quartz can appear white, green, or even red. Streak, color of the powdered form. For example, malachite gives green, white fluorite gives white. Transparency, minerals may be transparent, translucent, or opaque. Structure, can be fine, medium, coarse-grained, fibrous, and so on. Hardness is resistance to scratching, measured on the Mohs scale from 1 to 10. Talc has a Mohs scale of 1, diamond is 10. Fingernail is 2.5, glass or knife is 5.5. And last is specific gravity, that is the ratio of weight in air to the difference between weights in air and in water. Classification of minerals. Metallic minerals can be precious, gold, silver, platinum, ferrous, iron, and alloys like steel, non-ferrous, copper, lead, zinc, tin, aluminium. Non-metallic minerals, they do not contain metals. Example, sulfur, phosphates, nitrates. Even cement is a mixture of non-metallic minerals. Rocks are simply aggregates of minerals. They may be hard like granite or soft like soapstone. They come in different colors: black gabbro or white quartzite. The two most common minerals in rocks are feldspar and quartz. The study of rocks is called petrology, which deals with their composition, texture, structure, and origin. Rocks are classified into 3 families based on origin and appearance. The first is igneous rocks formed from magma or lava, also called primary rocks. Second, sedimentary rocks formed by deposits compacted into layers. And third is metamorphic rocks changed in form due to heat, pressure, or both. Igneous rocks are formed where magma cools and solidifies. They are generally crystalline and do not contain fossils. If they contain a high proportion of silica, they are called acidic rocks. They are lighter in color and less dense. Basic rocks, on the other hand, contains oxides of aluminium and magnesium, making them heavier and darker. By origin, they are divided into two classes. The first is plutonic, which is intrusive, are formed deep inside, cooling slowly, creating large crystals. Examples are granite, diorite, and gabbro. And the second is volcanic or extrusive rocks. They are formed when lava solidifies on the earth's surface, cooling quickly, producing small crystals. Examples are basalt, tough volcanic breccia. The texture of rocks depends on the speed of cooling. Slow cooling creates large crystals, and fast cooling generates small crystals. Examples include granite, basalt, gabbro, pegmatite, volcanic breccia, and tuff. Sedimentary rocks are formed by deposition, compaction, and lithification. They are usually layered and stratified, and the types include the first one, mechanically formed. They are made of accumulated rock fragments cemented together. Examples are sandstone, made of sand granites, grit, coarser sandstone, conglomerate are large rounded pebbles cemented, breccia are angular pebbles cemented, and limestones, shale, loess. Organically formed are from remains of organisms. Their fleshy parts decompose and leaving hard shells. Common ones are calcareous rocks like limestone and chalk. Geyserite and coal carbonaceous also belong under organically formed rocks. Chemically formed when minerals precipitate from solution. Examples are gypsum from evaporation of salt lakes. Chert, limestone, halite, and potash are other examples. Metamorphic rocks. Metamorphic word means changed form. These rocks are altered by heat, pressure, or both. Examples of transformations are from clay to slate, limestone metamorphoses into marble, sandstone to quartzite, granite to gneiss, shale to schist, coal to graphite. The types of metamorphism: first one is dynamic and the second is thermal. Dynamic metamorphism on crushing and breaking due to mechanical forces. Thermal metamorphism due to chemical alteration due to heat. Thermal metamorphism is further classified as contact and regional. Contact metamorphism when rocks touch hot magma, and regional metamorphism when pressure and temperature act on a large scale. The features of metamorphic rocks. The first one is foliation or lineation, that is, minerals are arranged in layers or lines. Banding, that is, alternating light and dark layers. The rock cycle. The rock cycle is the continuous process by which rocks are created, transformed, broken down, and reformed. It shows that Earth's crust is dynamic, not static. Igneous rocks are formed from cooled magma or lava, can undergo heat and pressure to become metamorphic rocks. Both igneous and metamorphic rocks can be weathered and eroded by wind, water, ice, and temperature changes. The broken fragments, called sediments, are transported and deposited. Over time, they are compacted and cemented into sedimentary rocks. Sedimentary rocks, when buried deeper in the earth, may be exposed to heat and pressure, turning into metamorphic rocks. All three types of rocks, igneous, sedimentary, and metamorphic, can be subducted into the mantle, where they melt back into magma. Once magma cools, the cycle begins again. The cycle includes short processes like volcanic eruptions forming lava, rocks instantly, and long processes like mountains slowly eroding into sediments over millions of years. Examples of transformation: granite, that is an igneous rock, weathered into sand, compressed into sandstone, sedimentary rock. Sandstone under pressure and heat becomes quartzite, that is a metamorphic rock. Limestone, which is a sedimentary rock, is recrystallized into marble, metamorphic rock. This cycle explains the interconnectedness of Earth systems. The atmosphere, hydrosphere, cryosphere, and lithosphere all play roles in breaking down and recycling rocks. In short, no rock is permanent, they are constantly recycled by nature, creating a balance in Earth's crust and maintaining the planet's geological activity. And that's a complete journey from Earth's composition to minerals, rocks, and the rock cycle. If you found this video useful, don't forget to like, share, and subscribe for more clear, exam-oriented explanations. See you in the next one.